Shall I become
Yeah.
visible? Okay.
Yeah, so hello everyone. Let me stop sharing my screen. Hello everyone. Welcome back to the CDP live stream where we do can't talk, pair programming for on issues within the community. Today we're joined with Rory Olson about two-way communication. Actually, let me show you. Say hi, Rory. You're on the big
Hello.
screen. um, so, yeah, Rory has been spearheading two-way communication, which is going to be bringing a lot of new functionality to the CDP. So, very excited to talk about this. We're also Rory's been also organizing other people to help on the effort. So we'll also be discussing on how you can get involved with working on this new feature. So I think we just kind of want to start and just talk about two-way communication and what does it mean and why are we talking about two-way. Well, currently in the CDP, we operate on one-way communication. So what does that mean? Well, when we send a message from this little red dot over here, this duck, it will travel through the network to the Papa Duck, and that's it. There's no way for us to send. We don't do anything where about messages coming back or say, "Hey, I got that message." So whoever was over here on the red duck doesn't know if the message was ever received by the Papa Duck, and so that's where two-way communication comes in. Um, and so what we can do with two-way, we could say, a duck can find out, hey, your message was received, and be able to even get responses back. So if in an emergency event, uh, survivors would be able to know, hey, someone's coming on the way. They'll be there in 30 minutes. And then other things you can do are being able to send commands to ducks. So let's say had a duck connected to a light, you wanted to send it a message, say, hey, turn on that light from a remote location. Another big feature would be implementing chats and being able to designate where you want that message to end up. So, if you wanted to send a message directly to a friend's duck, instead of doing a broadcast type chat. Another is remote device provisioning. So if you wanted to add ducks to a network and verify that they are supposed to be part of that network, using two-way, we'd be able to provision devices on the fly. And then other is whatever other mesh management, ducks being able to talk to each other and being able to do different things. So that does come with some challenges. Increased traffic. We're sending more messages than we were if we were one way. Another is because of the increased traffic, that's packet loss. So because since there's more traffic, that means that there could be potentially more collisions in the air. That means when two radio waves transmitting on the same frequency are collide with each other, and it ends up destroying the packet or corrupting it. Because when we do have a corrupted packet, we end up tossing it out. And then also if we don't program it properly, and a duck thinks, hey, I didn't get a message, and it constantly tries to resend the message, we could end up DDoSing the network with incredible amount of increased traffic, also known as the duck DOS. So that was a kind of a quick overview. Rory, is there anything you wanted to add to that, or?
Um, yeah, no, I think that was pretty good. Right now, yeah, I'm kind of just working on like this proof of concept, and yeah, there's definitely some level of theoretical networking principles that we still need to tackle.
Yeah. So, Rory, maybe you want to go into talking a little bit about Trello and that you have set up, and how where people can find out the most up to date information. If you want to share your screen.
Yeah, sure. Let me just bring that up. Okay, so yeah, this Trello board is just where I've been putting everything that I think might be kind of useful for other people to see. And yeah, as you can see, basically you've got the done column over here, just done very little with this really. You know, kind of have this test sort of scenario set up where I can send messages back and forth between a mama and a papa. And also I have a little bit of work done to where I can have a receipt sent from a papa for every packet that the papa gets. And yeah, so right now the kind of the scope that we're going for is getting the captive portal to get a receipt from the papa. So, you know, we've got this link from the mama to the papa and the papa back to the mama. Next step is kind of the captive portal, which we'll get to at another time, I'm thinking. But yeah, and then we've got some other kind of questions here. And then there's a whole ton of like scope that we can tackle later. But yeah, for now, like this left-hand column here is mostly for like persistent considerations. And I think maybe the most interesting one is this user story for Dimitri Disaster. It's this kind of user profile, user kind of story that I wrote thinking about what it would be like from a disaster survivor's perspective of like what's going on with what they see. And it kind of goes into a little bit of some discussion of like what would be happening on the network. So yeah, I mean, that's kind of like the primary use case that I was thinking about, was like having some disaster survivor talking to emergency officials and having those emergency officials kind of like respond back and letting this disaster survivor kind of know what message he's sent that's been received by the emergency officials, because that seems pretty key. So yeah, I'll hand it back to you, Nick.
Yeah, so this Trello board is open to the public, so anyone can join, or if anyone has trouble looking at it, let us know. We'll be posting the link on Slack and also I think in the description below, so that you can join and track the progress, or if you're interested in contributing, definitely reach out and let us know. So maybe Rory, do you want to go into how some of the stuff that you've already done and kind of go over a little bit what's working, and how is that done, and how does that contribute to your design that you've been working on so far?
Sure, yeah. So I haven't been working a ton with the design so much. I've mostly just been working on from like a proof of concept side. But the one thing that I've changed kind of like design wise is to add a receipt topic. So let's go into CDP packet.h. And what I've done is I've added this receipt type. So now basically any duck can send a receipt to another duck. And in the future, we might want to call this ACK. It's a little bit, I think ACK would be a better name. It'd be a little bit more like what TCP uses for its terminology. So bear that in mind. But
Yeah, so me for everyone to go in a little bit why it was important for him to put a receipt. This receipt here is, so this is in the topic part of our CDP packet, and topics are used by when the data gets to the Papa Duck. That topic is used for MQTT for which topic to be published to. So you can see here we have all different kinds of topics. Status is our more catch-all, and then we have our capital portal message, location for GPS, sensor, alert, health, And then also what's made not in here is also the ping topics. And these are all used to help organize data. And so the receipt is going to work similar to the ping topic, which we don't have in here, that the detector duck uses with other mama ducks, that to they check to see, hey, is this message a ping? Then I need to to do a certain behavior. So and so that's kind of why we can very space efficiently say like, hey, this is what type of message it is because we're only using 1 byte.
Yeah, nice. And hearing you talk there, like I didn't realize these were specifically meant for MQTT. So
Yeah. So yes. Yeah. So when you on the that's how when after you use the MQTT, that's how we grab everything, but then it makes it a lot easier for filtering based off of the type, and so as we continue to go on, we'll have certain topics that will, some of them will not require, like status will not require a certain format, but other things like location will require a certain, or expect a certain type of format. So that when on the data side, when it gets to the cloud, it's very easy to digest that data and make it useful.
cool. Sounds awesome. I guess I don't know if this is what you want to talk about right now, but I would be interested to talk about where this receipt kind of topic belongs, or
Oh, so yeah,
um,
so actually, where that would probably belong is in the reserve topics. So you
mm,
see here, yeah, so we have the ping and the pong there. This probably would be a uh, good one. Hi
uh,
UV, love you too. This is a got a comment that said love you all. Thank you for joining. So yeah, so that's so the reserve topics. They are used for uh, topics that are used for mesh, like how the inner working of the mesh. So that's a kind of I think the receipt will make sense. So actually, let's see. Yeah. Okay. Okay. Oh, yeah. For purposes of the demo that you've done. Yeah, that makes
yeah.
sense.
For right now, yeah, I'm thinking it's probably not best to change
Mm-hmm.
that now, because that
Mm-hmm.
would break the
Yeah.
communication I have going. Which
Yeah.
just to briefly mention, you can see right here some of the output. We've got a matched receipt happening there.
Mm-hmm.
Um, that happens every
Mm-hmm.
5 seconds. I've just got my Mama Duck sketch
Mm-hmm.
broadcasting every 5 seconds.
Mm-hmm.
So should we update this everywhere then? I've got it.
Don't you don't need to do it right now, but I think right now you're kind of on a roll talking about what you're doing. And just so we'll spend some time later to go back and fix it all once you've gone through the whole process.
Cool. I think actually I do want to just find everywhere I've got this and update it real quick. Just kind of shows also where this gets referenced. So yeah, here's one spot. This is in the Mama Duck, and
Mm-hmm.
basically, so this is in handle received packet. Um, so Mama Duck, she's gonna check if she's seen this before, and if not, then she's gonna do some things with it. One of the things is, like you can see, checking for ping, and in that case, she sends a pong and returns
Mm-hmm. Yeah,
the
so that's one of
receipt.
those reserved topics. Yeah, the ping.
Yep.
Yeah.
And yeah, so that should have been a code smell there to see that reserved topic for me. So cool. Glad we got this figured out.
Yeah.
But
This is why we do paired programming. We
yeah,
can to figure this stuff out.
yeah, for sure. So once we see that it's a receipt, we basically just parsing it and then checking the destination of the packet. And if the destination is equal to this duck's DUID, then we know that it's for us. And I'm going to skip a little bit ahead here. If it's not for us, then basically we just um, log that we've seen it, which is not really necessary. And then we relay the packet. So that's just to give the end there.
Do you, when you relay it, do you do the same process that you for normal relaying, or like because in the version you're working on right now, this the two-way we're going to be working is really coming into play when we're working on the bloom filter, which we discussed last week on last week's stream. Khalil did a presentation about the bloom filter, how it's going to work, and also how that expands the amount of space that we have in our packet. So right now, how we route and make sure that we aren't constantly sending messages is that we have a path. So we reserve a certain amount of bytes for this path, which limits how far the message can go, but also takes up valuable space that we have to be able to send more data. And so that's just kind of so right now is a little bit of a transition period where this will really come into play once the bloom filter, so we don't have to worry about it. But so I was just kind of asking, are you adding a path signature to this at the moment?
I'm relying on the previous code to, I
Okay.
think, add the path.
Mm-hmm.
Does that happen in preparing for relay?
Let's see. Is it prefer
Or
relay or prefer for sending?
or maybe in relay packet, I think.
Uh,
Let's
let's
find
see.
relay packet. Um,
Um, yeah, let's see. Duck radio. No, it's a duck packet, right? Yeah, prepare for relaying. Um, okay. Yeah, so then you have relay. And relay adds, let's see, buffer insert. Yeah. Yeah. Okay, so it does add, so if you if it so yeah, so if you do prepare for relaying, it will add the path to it. So
cool.
yeah.
Yeah. Nice. Yeah.
Yeah.
So as a side note, I haven't tested this with 3 ducks yet. I've only got two going, so it's good to think about that.
Mm-hmm.
So yeah, getting back to this then. Well, mostly just it's this block is the only thing that I've really added here,
Mm-hmm.
and basically um, there's kind of two things that can happen in here. One, it can reach this return, and in that case, it doesn't relay it. And two, it can just like not reach that return, and of course,
Mm-hmm.
just log that it found what is this? Yeah, some other things. So what will happen is that yeah, it'll check a couple of things, and then mostly it's gonna return
So
if
why
the
don't you just go
DUID
through what
is.
it's checking?
Yeah, sure. So first of all, there's just some like C++, implementation stuff. And I think I'll get to this in a minute, but we're just basically checking that the last message MUID is initialized.
Mm-hmm.
Um, we'll come back to that. But next up, if we find that the last message is MUID is what was being acked by the Papa Duck, then we will say, yes, we matched the receipt, and we're not going to really relay this on. That's what's happening right here. If you guys can read that
Mm-hmm.
down at the bottom.
Yeah. Yeah, why don't
Um,
you can tell it's a if you in the bottom left there's a stop scroll.
Yeah,
And
fair
then
enough.
it might be a little easier to read. So yeah, so you can see here
Very
it
true.
says that this is a receipt for me, and the it says that so it says Mama 001. That's me, and the it's for message 63 WJ.
Yeah, which does match this up here,
Mm-hmm.
which is what Mama just sent.
Mm-hmm.
Uh,
Yeah,
and
and that might look different, but that's because that's in hex. So those are
exactly.
all pairs. So that's what
Yep.
that's the actual byte buffer, what it actually looks like. Um,
Exactly.
so what you can do. So one thing I just noticed here. So if you go back to that,
Okay.
so you can see that you have a bunch of. So you take the auto scroll off. So where you see all those zeros, so you see in like where it says the DUID. So if you go up, yeah,
Mhm.
so you're right there. So that is the destination. So that is what in part of the header that we had reserved for target for the target for a message.
Mhm.
So because I think right now you put it in the where do you put the message or the duck ID
Um,
for the
in the
matching?
receipt packet,
Yeah.
I use the
Oh, you do use it.
DUID.
Yeah, okay, you do use
Yeah.
it. Oh, okay.
Yeah.
Why does it
Well,
not show
let
up?
me let me show you that, I guess.
Yeah, yeah. Let's go. Let's see that.
Yeah, so this is again in Mama Duck's. She's got a packet that she's received, and so she's put that packet into a CDP packet, which just allows us to kind of like parse out the pieces of that packet really
Mm-hmm.
easily. Um, and here it is, the packet DUID
Okay, yeah.
is what we're checking there.
Oh, okay. And then you have so let's see. Okay, so you're just going through each character
Mhm.
and making sure
Yeah,
that it's the same.
yeah. There's more concise ways to do it, but this
So
is
this was just more of just like, hey, this is the kind of a quick way to do it. And you plan to change it,
um,
or was there a particular reason you did it this way?
well, I could make a function that would compare two vectors for a given size, and basically what it would do is like in a for loop it would do this, right?
Mm-hmm.
And we can certainly do that if you want.
Well, I mean, what you because you do have access to the device ID, I think, yeah, and
Mhm.
so you can, and if you just turn it into if you just turn them into strings, you should be able to compare them, right?
Is that the typical way
Because
you do
you,
it then?
I think, because I think you can, I think because you can, I think you can cast it and then compare them, or I don't know, I don't know what's the best way to compare to. Let's see, maybe
Nice.
that's something to
So this actually
look
gets
at.
into something that I just recently added, which is a toString function. This returns the Arduino string rather than like a ST standard string.
Yeah, so
But
that's yeah. We want to move away from using the Arduino string. Yeah,
okay,
yeah.
interesting.
So we'll use the C string
Mhm.
function. Um,
Oh, you mean like stir comp?
yeah,
Um,
exactly.
okay, yeah. So we could definitely do that.
Actually, maybe that's just something we can try and see. Hey, does that work?
Mhm. Yeah.
And
Um,
if we just do that to if we replace it, maybe it breaks it. I don't know.
so with stir comp, let me see if I can um, look that up.
So,
Yeah. So this guy, it does compare two C strings, but they are expected to be um, null terminated, I think. Um, yeah. So
wait until
I
the
don't
characters
have.
differ. Oh no. Oh. So okay, so then it would get angry because there's no terminator.
Mhm.
Let's see. Is there? Let's see. I wonder if there's another way. So let's see. Because, but no, if you do C underscore. If you do the C underscore string, you can turn it.
Mhm. Yeah, for sure. So
Yes.
yeah, I can do that.
Yeah, if you do so, if you like, so if you did DUID and then dot C string
oh, oh,
C underscore
okay.
str.
Well, the UID is a vector, so I don't believe that that currently has.
Oh yeah,
I
it's
mean,
byte. Yeah, wait, it's a byte. Oh,
yeah.
but no, that shit's because I feel like I've done that. Let's see.
Okay. Well, I
Wait,
know
let me
that.
see. I'm not
I
sure it's
know.
the right way to do it though.
Oh, yeah, no worries. I mean, so like I know that this is basically what I can do to get that C string, and then we can use C or strcomp on it if that's
hmm
what you'd like to do.
Sorry. Oh, let's see. Oh me. Oh, is that how?
Yeah,
Oh,
it's
okay.
fun stuff with iterators. So
Uh, is that how to do it? Yeah, but I don't know. Yeah, we can. So let's see. What?
how about this? I know we can definitely do some. How about this? Some function called is equal. And maybe I'm just kind of like starting out with this, but I know we can do it A and a B, and we can return some true or false value um, based on what is equal or not. So let's do return. We're going to do a string there, get the C string. So we're going to do stir comp. I'm just going to kind of sort of one line it, if that's all right. And give me a second here. So the first guy is going to be A, and the second guy is going to be, oops, going to be A. And
Oh wait. So there's this. Their SSD has an equal.
what does an equal?
Yeah. Um. So I'm looking at this here. I'll put it in the chat. I'm not sure if that.
Oh, equal, nice. Okay,
Yeah, and then then you just put two vectors in there.
nice. Yeah.
I'm not sure if that does that work.
Oh, so yeah, that's kind of like something we already have then, so I don't need that. Okay, so I can do stir. What is it? Begin and oh yeah, begin of the first one.
And then begin in the second one.
Um,
What does SG equal
and
take? Let's see. All right,
okay.
so first, okay, so it's iterator one first, iterator one last, iterator two first, and it'll return a bool.
Yep.
Okay.
Nice.
Did you need so you don't need to include it on the top? I don't know. Is it throwing any errors?
Oh, I haven't tried to build it yet. We
Oh
can
yeah,
just.
sometimes it just throws an error. Anyways, I don't know. Well, I don't know. You're using Sublime, so maybe it's a little different.
Yeah.
But yeah, so that's it. So that's I made a little bit cleaner way. I don't know if it's a faster or better way, but
Certainly more concise. And we can make it more concise if you'd like
yeah.
by just making it
Yeah, if
something.
anyone who's watching has any ideas, definitely or knows what's maybe a better way to compare these, definitely let us know.
So this version here is about as concise as I can think of making it.
Uh-huh.
And we can certainly just put this inside of a duck utils is equal function. So it'd be
Oh,
like,
it gave you an error.
okay.
Let's see. What is it?
Let's see. Receipt is not a member of topics. Yeah.
Okay. Well, yeah.
So let's just change that real quick.
Yeah. Let's just move.
And getting back to this, yeah. So yeah, I could definitely do that though if your conciseness lends itself to readability. So
Yeah, I don't know. It's also something that I don't know if that's better, but yeah, yeah. Maybe there's just but maybe like the how you had is equal, where you just say, hey, you might be easier. I'm not sure,
okay.
but that's something we can decide. But okay,
Cool.
so it seems like it compiled.
Yeah, I do kind of like the idea of that because yeah, it just kind of encapsulates the minimal
Mm-hmm.
thing that you're trying to do.
Yeah, no, that's fine. Yeah, that sounds good.
So,
So
yeah.
actually, honestly, what you could do is make this you can make this yeah, just exactly just where it's generic, because there's going to be yeah.
Well, I guess equal. Yeah, is equal seems like a decent name.
Yeah. Mm-hmm. Yeah, and yeah, so I think equal the equal can take any type. Let's see.
Cool.
What does it say?
That's pretty neat. So,
Yeah. Yeah, no, I think that it looks pairs elements in range. Yeah, first two. Put those in range beginning at first two. Although I might not be. So technically this shouldn't happen, but I'm wondering if equal. If let's say the first one is smaller than the second one, that if it's equal up to that point, it says true, and it doesn't. Let's say if you had a situation where you had the sizes were different.
yeah,
I'm not sure. I'm not sure.
yeah,
It's just how this is worded in the stuff.
we've abstracted away the the detail there of
Yeah, exactly right.
like we've kind of hidden that important detail. So
But if that's true, it's very easy just to put in like just right above it is I think this is how we did the Ducky Tails. I think that's good. I think that if we find out that equals, it's like if there doesn't work if they're two different sizes, which it shouldn't happen anyways because of the packet format. The rest of the packet would be garbage anyways because it would be shifted. Everything would be shifted over. But we can very easily just put on top before we do the equal to say, hey, are the length of these two vectors the same? All right, and it's one line that would
yeah, that's true.
Yeah, so that's totally it's not a big deal. It's just something that to think about, and just we'll have to do some check. Not right now, but it's size yeah.
Yeah, something like that.
Yeah, exactly. Yeah, and that way we would. Yeah, so that would. I'm just like not sure by reading this documentation if it's because we do not put the range of the second iterator. So
Correct.
and it'll only check within the range of the first one. So, but yeah, I think we've covered our bases here. All right,
Cool.
we're
Yeah.
good to continue on.
Nice. Yeah, that is something I'll have to read a bit.
And also, what's
So,
great is you can actually use this for the second part right here that you have the last message MUID.
exactly. Um, yep, looks
Yeah, looks good.
cool.
Nice.
Yeah, that does happen a lot of places where you need to kind of like compare things.
Yeah,
So,
so that'll be yeah, that works really well. It just makes it very simple, and also it's part of Ducky Tails. We'll be able to use it everywhere.
yeah, nice.
Nice.
Um, so it may have broken something. I'm gonna rebuild here.
But yeah, so in the meantime, yeah, so we're checking if we've checked if the duck ID is same as the target ID,
Mhm.
and then we say okay, we got the receipt, we're not doing anything. Then if not, when you're doing so if it's not equal last message. So what? So when you're doing this last message part, what's happening here? Matched
So,
receipt not relaying. Oh no, above that on line 100.
mhm.
So what's this checking?
Okay. Yeah, so there's these three possibilities. One is it hasn't been um, initialized. Number two, both the DUID and the MUID are matched, and in that case, we kind of use this last message receipt. Like this is where we would uh, do interesting things. But yeah. So anyway, and then number three is that we can get a matching DUID, but not a matching MUID. So the message getting ACT is different. So
Mm-hmm.
basically, there could be another duck on the network that's sending out packets, and so we're seeing this
Mm.
the same DUID, and we just don't recognize that message, or else it could have been a previous message. And in fact, when I tested this out, I can start up the papa, and the papa will start up after the mama, and so the papa will get like some packet, and if the mama is sending it like every 5 seconds, the papa will get the first packet, act the first packet, and then meanwhile the mama will have moved on to expecting like some packet, like 2 packets after that packet, if that makes sense.
Mm-hmm. Yeah.
So
No, so that's actually very interesting. Especially the last part there, which it could very well happen.
yeah,
Um,
and so as part of what I think this receipt mechanism can do is it can actually cause it can be used to have a duck rate limit itself and like only transmit a single message at a time. So it would be kind of like invalid for a mama to send another packet until it gets an ACK back or some time limit
mhm.
expires. Um, and that's something that I think would be good to move towards for the sake of preventing network congestion. So
Yeah, no, that's good. And also, actually, maybe one thing you've been throwing around is ACK. Maybe you want to explain what ACK means?
right, yeah, ACK is a term that I'm borrowing from like TCP protocol. Um, it means basically acknowledge. So in TCP, you'll send a packet to say a server, and then the server will send back an ACK saying, "Yes, I got your message." And there's some mechanisms around that in TCP where like the server will count the number of bytes that you've sent basically, and send back how many bytes it's gotten. So like it's a little bit less or sorry, it's a little bit more intricate than what we're doing here. Um, but the same sort of concept applies, where it's just one thing saying, yes, I've received your message.
Mm-hmm.
Um, yeah.
Yeah. Mm-hmm.
So shall I continue on with the
Yes.
grand tour?
Mm-hmm.
Okay. So for any of these cases, actually, um, where is it? Where the DUID does match, it will return, and otherwise it will just relay that message. So
Mm-hmm.
I'm folding that. What have I done? Actually, oops, I clicked the wrong one. Yeah. So yeah. Anyway, so um, yeah, all this is like a match of the, or sorry, all this is a match of the DUID, and so in that case, the duck will not relay it on.
Mm-hmm.
So um, that's important because yeah, it's
Mm-hmm.
just the terminal spot for that receipt.
Mm-hmm. Yeah, that sounds
But
good.
yep. Okay.
Yeah, I'll go ahead.
Oh, I was just gonna talk about Papa now and a little bit about the duck superclass.
That's what I figured. Yeah, let's
Cool.
jump right into it.
Right. So starting out, I'm basically just gonna point out that when the mama here is trying to determine if the MUID matches, the mama will basically parse packet.data. And so what that means is that when Papa is creating a receipt, the Papa will, where is it? Um, add the its packet from mama, the MUID of that into the packet that it's transmitting as the data component. So yeah, I'm sorry, that was probably not the worst way to explain things. Let me come back to the beginning here. So um, yeah, so Papa here has received a packet. Um, we're, I'm putting the packet into a CDP packet so that I can parse it easily. And then I'm looking at like, okay, so I just want to log out some stuff, which isn't strictly necessary, but I'm saying packet, well, the receipt needs to go to the duck called, this is going to be saying like mama 001 in our case.
Mm-hmm.
And then the MUID is going to be whatever that message ID was.
Mm-hmm.
After that, of course, we do prepare for sending. So we say, we take the SUID, or sorry, SDUID, which is the source of the packet here in Papa,
Mm-hmm.
and we set that as being the destination. Let me just bring up the definition here. Yeah, so prepare for sending. The target device is the first parameter there, if you guys can read
Mm-hmm.
that. So once that is set up, then we say, yep, it's a Papa type that we're sending this from. The topic is receipt, and we're sending as the data payload that packet MUID.
Mm-hmm.
And then we kind of just send it. It's not too complicated after that.
Mm-hmm.
It's there's things that can go wrong, but from Papa's perspective, that's kind of the best that we could do at this point. And there's some things to talk about whether or not Papa should be sending this receipt right now or if it should send it later. But in this kind of proof of concept, that's what I've done. So
Mm-hmm. Yeah, and that's also something that So I think maybe the next step is to think about. So right now you are sending a receipt with a message ID as part of the payload. So how then? So how do we kind of play off of that and where we're also including critical information like, hey, we received your message and we're sending people over there. So how do we do that? Where may part of the payload component be say like, okay, we know for every receipt. So well also, or we can make this a different reserved topic. So we have like a response topic or something like this, or I'm not me, kind of spitballing a little bit here, is where the receipt is very purely the path is it goes from uh, ducklink, mama duck, papa duck. Papa duck sends a receipt immediately. Hey, I got it. Sends it back, and then and that's just a receipt. Hey, it was received. Then now you have another one where the originator is no longer the papa duck. It is no longer the duck link. It's now the papa duck, which we haven't had before. The papa duck, where is generating a new message. Usually it's like it's just receiving, and now it's just kind of just relaying a message kind of back. So now we wanted to say, we have a message for this duck. Now we need to generate one. So yeah, and then from there we can incorporate that into the capture portal or however we figure that out.
Yeah, yeah. There's definitely like almost infinite ways to do this. Um, the way that I had been conceptualizing this for myself was that we would be doing this like instant ACK of some sort, or quick ACK, I guess. And so that's going to happen on the order of seconds. And then in like kind of human time, some emergency operator is going to see the message that has been sent, and then kind of talk to some emergency officials, say like, oh, can we send some water there, or like, can we tell them to move to a better location or something like that. And that'll happen in the order of minutes, hopefully. And that sort of message will be more in the form of like a message rather than an ACK or a receipt.
Mm-hmm.
So that's what I'd been thinking about. Of course, we could like pair those together to where it's, I mean,
Yeah,
basically,
I think it's better that we separate them. When I started talking, I was like, oh, well, we can make it part of the receipt, but it makes more sense as is a separate response type. We can just create a new topic for that.
yeah, yeah, just some like push down
Mm-hmm.
topic or something like that. I don't know.
Mm-hmm. Yeah.
Uh,
Mm-hmm.
so yeah,
Mm-hmm.
um,
Yeah,
I,
anything. Yeah, so this is really awesome progress. I mean, you're really far along. So that's pretty exciting that it's already you have the working version. Although it seems like we did something that broke it.
yeah, that's right. um, Forbids declaration of is equal with no type. So yeah, we can fix that now. um, all right, so we've got hmm, do we need to
Wait,
add a
what's the
template
error?
parameter here? What's that?
Wait, so go to the what does the error say again?
Yeah. Forbids declaration of is equal with no type. So that is, that's Ducky Tail's 58. Explicit qualification in declaration of int. Oh, going off the side here.
Are you returning? Oh well, okay. So with no type, is it? It doesn't like that we're using T, but it would point to that, right? Declaration of equal with no type. Wait, what? What? Go to your Ducky Tails.
Yeah, so it doesn't like my declaration here.
Well. Oh. Well. Wait. So instead of doing duck utils, yeah,
Oh,
yeah,
is that just what it was?
and then you need to have it return a bool or right.
Yep. Wow. Yeah, I was totally on to like the next. I was like, it's just template programming being a jerk again.
Okay, so
But
that if that's the case, that would make sense.
yep,
I'm just like, wait a minute, it doesn't look like the function above it.
you're
Oh.
you're a C++ maestro. You've got it.
This is why this is this is hey, this is the benefit of pair programming, right? You have two sets of eyes, and hopefully
Mm,
you catch bugs faster.
yeah.
So there you go, pair programming in action. This whole stream is a success, guys.
Yep. I was thinking about these types, but nope, it's the type of the function, the one that it said. The compiler is usually right, by which I mean always. Um,
Mm.
so yeah, I guess while that's compiling,
Mm-hmm.
oh no, we got something here. Um, CDP packet has no member DUID. Oh, I bet I know what the deal is there. It's destination D.
Oh, okay.
So okay, I'm gonna
Let's
go
see.
back.
And then also the last so here on line 100 you have packet.data, is that right? Is it the data
Currently,
or is it, or you want to compare it to the UID?
currently I've put the MUID into the data payload, so
Okay.
that's here. So
Oh,
like,
that's right. Yes, that's right. It is in the data payload. That's right.
and that
Yeah.
does need to change to have a better kind of policy or better protocol.
Mm-hmm.
For example, we could ACK multiple MUIDs, or Papa
Mm-hmm.
could on some kind of interval ACK out like to multiple ducks, all of the MUIDs that
Oh, like a
he's,
batch.
yeah. So
That would actually, that's a maybe interesting conversation that we can continue
yeah,
on the open source, is like, how can we make this more efficient, because like, yes, if we send a message for every single received message, then that increases the traffic a lot. And if we can do, because anyways every single duck is going to be most likely get pinged by the message, so it would make sense that, hey, after like you have, and maybe you have either, by the time you have 50 messages, or have either you have 50 messages, or after a certain time period, then you send a batch
yeah,
response out. So like, let's say every 10 minutes you'll send a batch out of received messages.
yeah.
Um,
Something like that, definitely, and it could
that
be
that's
easily configured.
Yeah,
So
let's definitely make sure to make a note of that, because I think that is definitely would make things. Yeah, let's add a card in there for that.
yeah, I actually have better receipt format here.
Oh,
So
nice.
this is the one that I'm talking about here with broadcasting
Mm-hmm.
acts to, or yeah, multiple acts.
Oh, okay. So you have it
Multiple
here. Yeah. Oh,
yeah.
awesome. Okay. Yeah. So no, that I think that's definitely a very interesting idea, because traffic is probably one of the biggest concerns with two-way and receipts. I mean, being able to get a receipt is even if it's a little bit slower, makes a big difference. And so, okay, we compiled. It's happy now.
Yep. It's not happy enough though. We're not getting the receipt received
Uh oh.
thing. So I'm just going to copy everything there because I've developed this habit of just saving temporarily all of my output for one duck or the other, so I can like debug the other.
Uh-huh.
Um, and then I'm going to switch to the other duck. So that's over on this other port. And yeah, what is the Papa seeing? The Puppet, I'll pause it there. Yeah, so he's sending a receipt. Um, so Papa seems like he's
Yeah, I
doing
see.
fine. So yeah, okay, I just wanted to make sure. Now let's switch back to Mama, and we will be doing that there. So annoying that you can only get serial from one at a time. But okay, so what's happening here? We've got handle received packet, packet relay done. That's going to be in Mama Duck here. Oh,
Mm-hmm.
yeah, it's done. Well, we didn't pass the part that we were interested in, so.
So what it did is it said, hey, no, this is not it. The is equal didn't work,
Mhm.
right?
Yeah, and
So
I,
it said that, and so what it's doing is it's just relaying the Papa Duck, right? Instead of saying, hey, this is for me. It's
mhm.
so there's something wrong with the equal. So for whatever reason, the equal is returning false.
Right, I'm kind of wondering, did I somehow mess up it even getting into here?
Oh, because you didn't get
Um,
any of those other messages.
yeah, because any of this should make some log output, um, or this should put something into the log about receipts. So I'm thinking it didn't get into here because all branches of this
Yeah, didn't
log
trigger.
somewhere.
Yeah, okay, so that's a problem.
B packet. So um, it might be that I've got different receipt numbers right now. I thought, you know what?
Well, you
That's
had
probably it.
16. You
I
had
probably
16 before.
I probably saved it as 4 and then forgot to change it back to 16 and save it. So let's assume that's what it was and continue on our merry way of like talking about one more thing, I think, which is in the superclass duck here, we have the last message MUID and the last
Mhm.
message receipt. So I don't know. I think these are interesting to talk about from a C++ perspective. Um, I've initialized last message receipt to true, which I thought this was interesting to talk about
Mhm.
because, like the comment says here, if we're going to use this to throttle outgoing packets, then we probably want to start in a state that says like, yeah, we're all good to go. Does that kind of
Mhm.
make sense to you, Nick?
Yeah. So wait. So see true. Is start out in a state in case we're not waiting for a receipt. So wait. So go over this again.
Okay,
Wait, what do you mean?
so let's find all of the instances of last message receipt. So I'm just gonna Control Shift F for everything. We've got just the initialization or the declaration, sorry, here. And then in
Mhm.
Mama Duck, we saw this section where if Mama Duck makes a match, then we set it to true.
Mhm.
And then there's one more kind of interesting situation where um, Mama Duck also, when Mama Duck sends a message, and I've got this actually just in Duck right now, we set the last message receipt to false because that message that's going out like right here in this code has not been act yet.
Mhm. So you're saying that this could be used to make a duck wait to receive a response from the Papa Duck.
Yeah, like I don't know, I don't think this would be really quite what we're wanting to do, but theoretically we could do something like this. So we could say, if not, act, then we return. So, just as kind of like a way to give you an idea of something similar to what we could do.
Mm-hmm.
Um,
Yeah, yeah. Um. So yeah, okay. So that's something that we an option that we can put out there. I mean, that's something that I think if someone might find valuable. I don't know. I don't know if we want to prevent if because it does take time for a message receipt to come back. Then if they're just not transmitting anything. Oh, but this is only for send data or.
yeah, this the way that I've been conceptualizing this is that any duck would hopefully have just like one active packet,
Mm-hmm.
or for an emergency
Mm-hmm.
relief scenario, like um, to prevent congestion. If each, I mean, there's just so many things that here that I
Mm-hmm.
don't know, but
Uh-huh.
from a network congestion standpoint, if each duck only has one packet that it's kind of like trying to send or resend, then it kind of helps to reduce the network traffic
Mm-hmm.
by doing that.
Yeah, at
And
least.
there's like, yeah, sorry, there's just like an obvious version of saying that, and then there's kind of like a whole lot of
Mm-hmm.
extra thinking that we could do about it. Of like
Yeah.
maybe it's some kind of time limit or something that each
Yeah.
duck.
So how are you storing the message IDs
Mhm.
that
the
you sent?
the Yeah, so the last message MUID, it's first of all, it's this member variable within duck, and here's kind of where it gets assigned
Okay.
to. It
So
gets
so we only can store one at a time here.
That is what I've currently set up, and oh, sorry, and yeah, like the possibilities are wide open. I was imagining that, like, kind of instead of just doing something kind of simple like this last message receipt, we'd probably want to have some kind of like timer that times how long it's been since a message has been
Mm-hmm.
uh,
Yeah. So I think what we would want is to build a system where we can store be waiting on multiple receipts. Maybe that's also something to put on the Trello. I don't know if you have that in there. Is that to add a way for us to be able to wait for on multiple receipts?
right. Yep. Okay.
Mm-hmm.
Yeah, that makes sense.
Yeah, yeah. Because I think that will be valuable too, just because of the nature of the network that it's slow, might take some time, and then there will need to be some thought put into it.
uh, um, that kind of makes sense as a
Yeah,
good explanation. Okay.
yeah. So we can start with that. I mean, also maybe we don't end up doing it, but we'll see how. Let's see. Is it? Oh, it gets it now.
Yeah, we
Okay.
fixed it.
All right. Awesome. This is really cool.
Mhm.
So great work. Keep at it. We'll continue the discussion in the open source and Slack. And I think next week we're going to try and work on bloom filters, and then hopefully, once we got that integrated, then we can combine this with that. Or we just have another stream. Maybe we'll have we'll do both or something like that. Quite flexible. But awesome. This is really cool. Great progress. And, we'll continue talking in Slack.
Cool. Yeah, thanks for having me on, Nick.
Yeah, thanks for the work that you've done. It's really awesome. All right, and thank you everyone for joining us today. We'll see you next week on our stream. Thank you.